Hello, and welcome to the next episode in the Amazon Personalized Deep Dive series. In this episode, we will be looking at how to get recommendations from the models you create in Personalize and some patterns for integrating recommendations into your application. My name is James Jory. I'm an AI Solutions Architect with AWS, and I will be leading you through this episode. Before jumping into the topic for this episode, I wanted to quickly recap where we are in the video series. We've broken up the series into 4 areas that generally map to the developer journey with the service. The series dives progressively deeper on topics ranging from how to prepare and manage your data for Personalize, how to select and configure the appropriate recipes or algorithms for your use cases, how to train models, how to retrieve recommendations from your models to integrate them into your application, and how to operationalize Personalize for production. If you're just getting started with Personalize, we recommend starting with the introduction video and watching the series in order. In this episode, we will be focusing on the topic of inference. Inference is the machine learning term for asking a model to make a prediction. In the case of Personalize, this is where we get recommendations from the solution, or more specifically, the solution version you created based on your data. So with that, let's dive in. There are 2 general approaches to getting recommendations from Personalize. Real-time recommendations are best combined with interactive user experiences, such as pages on your website or views in your mobile application, where users are browsing and interacting with content. The APIs used to get recommendations in real time are transactional in nature, meaning they're typically called in response to some sort of user activity in your application. There are 2 real-time APIs. Get recommendations, and get personalized ranking. The one you call depends on the underlying use case and the recipe that you chose for that use case. We will go into more detail on these APIs in this episode. The real-time APIs are synchronous, low latency, and auto-scaling. This means they follow the request-response model, are designed to be integrated as part of the flow of rendering your user experiences, and will adapt to the traffic patterns of your application by auto-scaling resources as needed. The runtime requirements are implemented in what's called a personalized campaign. You create a campaign for each solution or model that you train. The real-time APIs also have the ability to adapt recommendations to meet your users' changing interests and intent. This is only supported for the user personalization, personalized ranking, and the legacy HR&N recipes, and you must stream new interactions into an event tracker to enable this behavior. In cases where the current context of the user influences their behavior, you can provide relevant context information in your API call to help Personalize make even more relevant recommendations. For example, if your users engage with content differently, say when they're using your mobile app versus your desktop app, you can provide the user's current device as context. We'll talk more about event trackers in a moment. Finally, the real-time APIs support filters, which allow you to combine business rules with recommendations to create multiple user experiences from the same campaign. We will be covering filters in more detail in a subsequent episode. Batch recommendations are an alternative to real-time recommendations that allow you to retrieve multiple recommendations from Personalize at once. Batch recommendations are a great match when you have downstream batch pipelines, such as email marketing campaigns, where you want to target a large number of users with messages that include personalized recommendations. You can also use batch recommendations when you want to cache recommendations in a separate data store. The API for batch recommendations involves preparing an input file in JSON format that includes all of the users or items for which you want recommendations, defining an output location in S3 where the results should be saved, and then creating a batch inference job to produce the recommendations. This means that batch recommendations process is asynchronous. In other words, you create the job and then you have to wait for it to complete. Since batch recommendations run against a solution version, a personalized campaign is not required. This will allow you to avoid the cost of a campaign if you don't need the solution for a real-time use case as well. Now, it should go without saying that batch recommendations are point in time, meaning that they don't adapt to real-time user behavior. This means that you have to retrain your model to incorporate learnings from new interactions before running your batch jobs. Lastly, batch recommendations also support filters, just like real-time recommendations. Next, let's dive a little bit deeper into both of these approaches. So we'll start by taking a closer look at real-time recommendations and a high-level diagram of how the various personalized components work together and with your application. You start with creating a dataset group, schemas, and datasets representing your items, interactions, and user data. These steps were covered in detail in the data-related episodes in this series, so be sure to check out those episodes if these are new concepts for you. After importing your data, selecting the recipe matching your use case, and creating a solution, you train a model by creating a solution version. This process is covered in more detail in the training-related episodes. At this point, you're ready to create a campaign. Campaigns are created using the Create Campaign API. You will create a campaign for every solution version that you wish to use for real-time recommendations. So in this case, we're just showing a single solution version and a single campaign. If you were building out multiple personalization use cases with different recipes, you could create multiple solution versions and multiple campaigns from the same datasets. Now, once you have a campaign, you can integrate calls to the campaign in your application. This is where calls to the Get Recommendations and Get Personalized Ranking APIs are made to retrieve those recommendations. Now, in the previous slide, I mentioned that real-time recommendations support the ability to adapt to each of your users' evolving interests. This is supported by creating an event tracker in Personalize. An event tracker provides an endpoint that allows you to stream interactions that occur in your application back to Personalize. The Put Events API is how you do this. AWS provides the Amplify framework that can be integrated into your web and mobile apps to make this easier. It's also quite common to use a customer data platform such as Segment, which has an integration with Personalize to stream events directly to the event tracker in your AWS environment. The event tracker performs two primary functions. First, it persists all streamed interactions so that they will be incorporated into future retrainings of your models. It also influences any active campaigns in the same dataset group so that future recommendations for the same user will adapt to that user's current interests. This is also how Personalize cold starts new users. So when a new user hits your site, Personalize will recommend popular items. After you stream in an event or two, Personalize will immediately start adjusting recommendations. So we've covered a lot of theory and concepts on this slide, so let's switch over to a demo to see how it all works in action. All right, here we are in the AWS console, looking at the Amazon Personalized service page. And this is the dashboard for the Movie Lens POC dataset group. And this is the same dataset group that was used in the mapping your data and the use cases where you trained your models. And so we won't repeat the work that was done in those videos, but just to kind of show you where we left off there is we have the two datasets, one for the interactions that represents users engaging with movies, and then the items dataset, which has information about the movies in the dataset. The training episode also trained 3 solutions across the three core use cases of Personalize. And so let's take a quick look and see what we have here. So for the user personalization recipe, our solution, we have that was trained with the user personalization recipe. We have a solution version, which is a trained model for this solution. When we go over to campaigns, though, we see that we do not have any campaigns yet for the solution versions in this dataset group. So what we'll do here is we'll create campaigns for each of our 3 solutions. Start with the user personalization. And I'm going to, you'll see that I'm naming the campaigns the same as the solutions. And I'm just doing that to make it easy to connect the two together. So just purely for ease of following the demo. The solution version is if you had multiple versions here. So if you were going through doing multiple trainings of the same solution, you would have multiple versions here. We just have one in this case, so we'll just pick the one there. Now, the minimum provision transactions per second is a really important field when you are considering the properly provisioning your campaigns. And so what this number represents is You're telling Personalize, I want Personalize to support this as my baseline or my low watermark for request volume that I expect to send to this particular campaign. So you want to set this value as low as possible based on what your low watermark is. 1 is the smallest value. And by setting this at a low value, you're essentially letting Personalize do the auto scaling for you. So Personalize will scale up the resources as volume increases and then scale back down. Because you're charged based on the maximum of either your actual volume or this minimum provision TPS, you want to make sure that you're not over provisioning your campaigns so that you're not paying for resources you're not using. So we're going to leave it at 1 for all 3 of our campaigns. And we also have another section down here that's campaign configuration. And we're only seeing this because this particular solution was created with the user personalization recipe. This recipe has a special algorithm that will allow you to balance exploration with exploitation of recommendations in your campaign. And exploration is where you can recommend items that are either new or introduced in your catalog, or items that you don't have a lot of interaction data for. And so it's a great way to expose your users to cold items or new items more frequently so that Personalize can learn from the interests of those new items. You control how much exploration this campaign will do by essentially moving the slider to the right, is saying I want a more heavily weighted exploration, or all the way to the left, which means no exploration. So with no exploration, you're essentially relying on the relevant recommendations that come from the underlying model. So we'll go ahead and set this back at the default, which is 0.3, which is essentially a modest level of exploration. You have another field here related to exploration, which is the item age cutoff. And this controls how old your items are from an interaction perspective that will be considered cold. So the larger number here, the more items that will be considered cold and the more they will be included in exploration. So we'll leave it at the default of 30 days and go ahead and create this campaign. So what we've done here is we've initiated the process of creating a campaign in the background. At this point, we can't get any recommendations from this campaign because it's not in an active status. And so it can take between 10 and 15 minutes for a campaign to get to an active status. And then once it's active, we can start making calls against it. So while we're waiting for this one to complete, let's go ahead and create campaigns for our other 2 solutions. We'll do Sims next. There's only 1 solution version there, and we'll keep the min TPS at 1 as well. Okay, so when we go back over to the campaigns page here, we see that these 3 campaigns are either currently being created or they're pending to be created. So we'll go ahead and pause here and wait for these campaigns to finish creating, and then we'll come back and start making some get recommendation calls against them. All right, we're back, and it looks like our 3 campaigns have been successfully created. So let's go through and see how we can get recommendations from these campaigns right in the console. And then I'll switch to some coding samples to see how you can use the Personalize SDK to get recommendations. So we'll start with the Sims campaign first. With Sims, if you recall, it's given an item, it'll recommend similar items. So I'm going to go ahead and put in an item that I know is in the movie lens dataset. We're going to leave filter blank for now, since we're covering that in depth in a subsequent video in this series. What we get back is a list of items that are similar to item 589. We also get back a recommendation ID, which we'll talk more about that in another video that talks about modeling on impression data. And then scores are blank for Sims. And so we don't get scores for Sims campaigns, but we do for the others. So we'll talk about the score column for those other campaigns. Next, we'll look at the user personalization campaign. So this one is backed by the user personalization recipe. And what we need to input here is a user ID. And we'll leave filter at none. And you can also provide context information. So if you recall from earlier, context can be any information that helps that affects the behavior of your users and their recommendations. So the example is maybe they interact with content differently when they're, say, on a mobile device versus your desktop application. And so you can provide their current form factor as context, and Personalize will alter the recommendations based on that context. Some other examples might include time of day, weather, the user's current location, anything that's contextual to the interaction. Okay, so we get back a recommendation ID just as before, a list of items that are recommended for this user. The score values here is this is a floating point number between 0 and 1.0. And the values for this particular campaign and these recipes and this for this use case are based on a score of all items across your entire items data set. So the more items you have in your data set, the smaller the absolute values of your scores are going to be. But if you added all of them up across your whole data set, they would add up to 1.0. So it's important not to read too much into the absolute value of the scores for the user personalization use case, but instead use them as relative to each other within the same recommendations response to get a sense for how strong some of these items are in relevance versus the others. And the last campaign is re-ranking. So re-ranking is given a user and a list of item IDs. The campaign will re-rank them. And so we see those 5 items have been re-ranked in a different order. The score is a little bit different here, though. The score for personalized ranking, these 5 scores will add up to 1.0. So the scope of the scoring for personalized ranking is just this particular response, not across your entire items data set. So it's just an important difference to keep in mind there. So since these item IDs that we've seen in these responses aren't very meaningful, they don't really tell us a whole lot about what's being recommended, I'd like to switch over to showing you some coding samples that will hopefully make these responses a little more meaningful to you. And so we'll provide all this code with the videos so that you can spend more time looking and running this code yourself if you'd like. So there's some Python scripts here. This is written in Python. You can use any language supported by the AWS SDK. So these 3 Python scripts will exercise the 3 different campaigns. And what we're using as input here for data is I've downloaded the interaction CSV, which was used to train the model. So these are all the interactions for all users across the movies, the timestamp, and the event type. If you want to know more about this data set, go back to the episode on mapping your data. And then there's the movie CSV, which came with Movie Lens, that has all the movie IDs, their title, and their genres. And so we're going to use this to look up those IDs to display more meaningful movie titles in our responses. So we'll start with the user personalization, and you can pass on this script here. Let me just show you the important bits here. Is this function here is what is actually calling the get recommendations call on Personalized runtime. And so that is the client for interfacing with personalized campaigns. We're passing the campaign ARN, the user ID, and how many results we want back. And then we're looking up the movie titles and just putting them into a pandas data frame so that we can display them in a more intuitive and meaningful way. So you pass the campaign ARN on the command line to the script. You can optionally pass a user ID, or if you don't pass a user ID, it will look up a random user from the data set. We're going to get the interactions for this user. These are all the interactions from the CSV for this user, and then we'll isolate the top genres across all those interactions to get a sense for what is this user interested in movies. Then we'll actually get recommendations from Personalize, and we'll see how those recommendations stack up against the popular genres for the interactions of this user. And then we'll compare those, the top genres in the recommendations against the user's interactions and hopefully see a pattern in the recommendations. So let's go ahead and run this script here. All right, so we loaded the movies, we loaded the interactions. I didn't provide a user ID, so it randomly selected user ID 207 from the interactions dataset. And here's a sampling of the last 20 interactions for this user, and we can see the genres over here. The more interesting information is these are the top genres for this user based on their interactions. So not a whole lot of interactions. Interested in thrillers, drama, and adventure. So we'll see how the recommendations stack up. So here's the recommendations for this user. You can see the movie titles and then the genres over here. Then the script will take those top genres from up above and then isolate the top genres from the recommendations and display them side by side. So we should see some correlation between the two. Not a lot of interactions for this user, so we don't have a lot of data to go on. But their interactions indicated they were interested in thrillers, dramas, and adventure. So we see drama, adventure, action. We see sci-fi is up here a little bit higher than in the interactions, but again, we didn't have a lot to go on. Let's go ahead and run it again it'll select a different user this time. And so this user has quite a bit more interaction. So they're very interested in action, comedy, and adventure. So let's see how that came out. So here's the recommendations: comedy, action, thriller, adventure. So the recommendations are much better for this user because we have more historical data. Now let's look at the Sims script here. So this script is you pass in an item ID and it will look up similar items and then display the movie titles. So we'll go ahead and run this one. All right, so here's that 589 that I showed you in the console, which is Terminator 2 Judgment Day. It's from the action and sci-fi genres. And so the similar items to Terminator 2 Judgment Day based on these interactions: Jurassic Park, Braveheart, the first Terminator, Fugitive, Speed, Crimson Tide, GoldenEye. So definitely we have a lot of action here. We have some sci-fi in these recommendations. So these seem to be pretty good similar item recommendations. The last script does the personalized ranking. And so with this script, you can pass in a user ID or it will randomly find a user ID and it will randomly select 20 items to re-rank. Then it will call, let's look at the main function here. So it will call the get personalized ranking API. So it's different than get recommendations. Pass the campaign, the user ID, and then a list of IDs to re-rank. We'll look up the movies and see what the results are. All right, so these are the 20 item IDs that were randomly selected. Here's the list of them. So they're unranked at this point. And we'll call, based on this user, we'll get a sense for what this user is interested in. So this user is very interested in comedy, drama, and action. So let's look at the re-ranked items here. So comedy, romance, drama. Then we'll compare the unranked movies to the re-ranked movies and see that we have a difference in order. So we've had some re-ranking here, or Personalize is modifying the order of these, or re-ranking these items based on this user's interest. So I hope that gave you a good sense for how you can use the different campaigns and how the different APIs work. We'll switch now to look at batch recommendations. All right, so we just finished looking at how real-time recommendations work with Personalize. Now let's turn our attention to batch recommendations. We'll walk through a similar diagram as before, where you start with your dataset group and your datasets, and then you train a model by creating a solution version. At this point, you're ready to create your batch inference job. Now notice that we only need a solution version here and not a campaign. Before you can create your batch job though, you need to create an input file. This file is in JSON format and includes all of the user IDs, or in the case of Sims, your item IDs, that you wish to retrieve recommendations for. You create your batch job, passing a reference to your input file and the solution version, as well as some other parameters that we'll look at in a moment in a demo. The batch job starts in the background and processes your input file. An output file, also in JSON format, is written back to S3 at the location you specify when you create your job. Once the job is finished, you can process the output file in any downstream batch processing, such as email marketing campaigns that we discussed earlier. Now let's take a quick look at how batch recommendations work in action. Okay, here we are back in the AWS console in the Amazon Personalize service page. And we're back in our same dataset group. And we're under the batch inference jobs menu option. So creating a batch inference job, there's several input parameters, including the batch job name. We need to provide a service role that Personalize will assume to be able to access our S3 bucket. And then we'll provide a solution version, the location of our input file, and where to write the results. So before we can create this job, we need to set up some of these requirements. So let's start by creating the S3 bucket that will need to store our input file. So I have some information, I have some IAM roles and the bucket names already defined here. So I'm just going to grab these from my clipboard and go ahead and create a bucket with this name. Accept all the defaults. All right, so our bucket's created. Now we need to set bucket permissions to set a bucket policy that will allow Personalize to access this bucket and perform the actions that it needs. So we'll go down to bucket policy and edit, and I have a bucket policy already prepared here. So the JSON is ready to go. So what we're doing here is we're allowing the Personalize service to be able to access this bucket and being able to get objects, list objects in the bucket, as well as put objects. This is where the output file is going to be written. So let's go ahead and save the bucket policy. All right, so our bucket is set up. Now we need to create that role that will allow Personalize to be able to access the bucket, assume that role, and be able to access the bucket. So go ahead and create a role. It's going to be for the Personalize service. Then we will create a policy. And I have a policy already written down here. That looks very similar to the bucket policy. So let's review that. So basically the same actions against the bucket here. And this will allow this role to be able to access the S3 bucket. So let's go ahead and save this policy. Go get our name for convenience. All right, so our policy has been created. So now let's attach it to our role. Refresh. Tags, review. Okay, great. Now our role has been created. So let's go ahead and grab while we're here, we'll grab the ARN on the clipboard for this role. Come back over to our batch job, and we will go ahead and paste that ARN in there. All right, so let's give our job a name. We're going to use the user personalization. Pick the solution version. There's only one here. We'll take the default of 25 recommendations. We can set the exploration here. So the exploration weight, we'll leave these at the defaults. Now we need to get our input data location. So we haven't created an input file. I have a script that can be used to create the batch input file. And so I won't spend too much time looking at the code here, but essentially you can pass in a user ID, or it will randomly select a user ID out of the data set and it will create the file. So let's go ahead and run this script. We pass the bucket name because it's going to create the file and upload it to the bucket. So here's our bucket name on the URL. We're doing the user personalization use case. So let's go ahead and run this. Okay, and here's the input file that was created by the script. So let's take a look at that. It's just a series of single JSON documents that are separated on individual lines where the input is the user ID. So the script randomly picked 50 user IDs and built this input file. And it uploaded it to the S3 bucket. So we'll go over to back over to S3. And we see that there's an input folder here. And here's our file. Okay. So let's go ahead and grab the path for that file. And then for the output path, we're just going to, instead of the input directory or folder, we will write it to output. And so you need a trailing slash there. So this is the location where the output file is going to be placed. We'll go ahead and create our batch job. And our batch job is create pending. And so it's going to take some time for Personalize to provision the resources to process our file. And so there's a certain amount of fixed overhead with every batch job to be able to provision those resources. So it doesn't matter really how small or big your file, there's always going to be that overhead, and then it will process your file rather quickly at that point. So at this point, we'll pause and wait for this job to complete, and then we'll look at the output. All right, it looks like our batch inference job is now complete. Its status is transitioned to active. Let's go over to S3 and look at in the output location that we specified. So if you recall, when we created our job, we told Personalize to put the output file in the output directory here in this folder. And sure enough, we have an output file in here. So let's download this file and take a look at it. Of course, you could do all of these things using the SDK rather than the console. I'm going to save it right into the location of that Python project that we looked at earlier. All right, so if you recall, this is our input file here, and we have the user ID and the value for each user. We randomly selected 50 users in this input file. Here's the output file that I just downloaded here. And you can see there's a single JSON document for each line, just like the input file, but the format's a little bit different. So the Personalize has echoed back the input value that we sent in. And then there's a new output document here with recommended items. So we can see the list of the recommended item IDs. And then we also have the scores that correspond to each recommended item ID. And then you can process this file by reading in each line. So it's a line delimited file of JSON documents, and process each document and incorporate that into your downstream batch processes. So with that, we'll end the demo on batch recommendations and wrap up the episode. Before closing out this episode, I wanted to remind you of the other resources available for working with Personalize. The Personalize developer documentation includes detailed information on how to use Personalize and the Personalize APIs. We also regularly publish blog posts that go into detail on new features, customer examples, and integration patterns. Since sometimes it's helpful to see sample code on how to implement a feature or build an integration, we have several resources available on GitHub that will walk you through using a feature or deploying a reference architecture. Finally, we have some complete end-to-end demos, such as the retail demo store, that you can deploy into your AWS account to see how a full stack integration with Personalize can be built. Since AWS is constantly adding new features and improvements to Personalize, periodically checking back to the latest developer documentation updates, the Personalize blog, and the GitHub resources is a great way to stay current with the service. So with that, I'll wrap up. I hope this episode gave you a good sense of how to get recommendations from Personalize for both real-time and batch use cases. Please join us for upcoming episodes, where we will dive deeper into other topics related to Personalize.